So how do you begin with something like this? Well, obviously not trig substitution, but I do see, which is start to get a sense of, two functions multiplied times each other. So when there's multiplication of functions and no fractions, that would make me think of parts. So I'm going to think of letting u equal the function I know the derivative of, and then dv equal the rest. So let's do with the derivative. So doing chain rule, square root of 1 minus x squared times the derivative of x squared, 2x. And then v equal x squared over 2 dx. All right, so let's put that together. So I get uv. Oops, I didn't mean to put that dx there. Sorry about that. So uv, so x squared over 2, inverse sine of x squared, minus the integral of v du. Okay, x squared over 2, 2x, 1 minus, and now I can simplify that, right? All right, whoops, come back. Okay, so then I'm going to say, let's just rewrite this one more time. It can be so helpful. So if I cancel these 2's, so then I would get an x cubed in the numerator, and there it is. You're looking at that. You see it? You see it? U equals the inside. Du works. So easy U substitution. So it's important to carry all of the beginning part along. And then if I take the antiderivative, putting the U in, so I would get a negative 1/4 times a negative, a positive 1/4, and then U to the negative 1/2 power. And finish it up with all the details. So I get a positive 1/4, and so I get u to the 1/2 over a 1/2, or times a 2. So x squared over 2 sine x squared plus a 1/2 square root of 1 minus x to the 4th plus c. All right, so that was number 2. Let's look at number 3. Number 3 obviously must be partial fraction decomposition, because we've got polynomials going on. This is the only method we have to deal with everything is polynomials in the integral. The first step is to make sure the degree of the numerator is smaller than the degree of the denominator. It is. Okay. Then we need to make sure the denominator is factored. Okay, it's not. So I'm going to take the time to rewrite this without the integral and then factor the denominator. All right, now I can know how to set this up. I get a over an x plus a bx plus a c over an x squared plus a 4. So then remember, the idea is to multiply both sides by this denominator on the left-hand side, right? So multiply both sides. Okay, so the left-hand side turns out to be just the numerator, right? And then on the right-hand side, so think about it, this times this, I get a times x squared plus 4. And then this times this gives me a bx plus a c times an x. Then the parentheses are very necessary. Now I'm looking for a good number to plug in. I'm thinking x equals 0 is a good number. It's the one good number, right? So when I plug in x equals 0, that's gone. Plug in x equals 0, I get negative 4 is equal to a times 4, right? So that means a is negative 1. Got one number. All right, now I need to think about how am I going to approach finding the other numbers. How about we look at the x squared terms? So if I look at x squared terms, on the left-hand side, I see 2x squared. So what do I see on the right-hand side? Oh, I'd have ax squared. Oh, and from these two terms, I'd have a bx squared. Well, wait a second. I know that a is -1. So that gives me 2 equals -1 plus a b. Because I don't need to carry the x squareds. I'm looking at just the coefficients. The numbers in front of the x squareds have to add up. So this gives me b equals 3. All right. So then, oh, hold on a second. I made a mistake. I wanted to make sure I corrected it. That was a +4, right? I just wrote it down wrong. That's a +4. And so that's a +4. Then, let me see, where did I make the mistake then? 2x squared. Oh, so then if it's a +4, so that means +4. So that means a is +1. Okay, so a is +1. So if a is +1, that means b is 1. Good thing I had some solutions next to me. Okay, so a is 1, b is 1. So let me just write that above here, keeping all my information stored. So it's so important that you keep all of this ready to go because you have to use it all when you plug it back in, right? Okay, so a is 1, b is 1. Okay, so now I'm on the mission to find out what c is equal to. So this is the line we want to go to, right? So let's think about this. So c is in front of an x term, right? So let me make some more room here. So c is in front of an x term, but be careful. It's so easy to make a mistake here to find all the x terms. So on the x terms from this side, I see a -1 for the x term, right? For the x term on the left-hand side. No x terms here. And on this side, I would just get a cx, correct? And so that would mean that c is, sorry, shouldn't put the x there. That c times x is the x term. So c is -1. Look at that. Okay, got it. So now let's plug all of that back in to the original c equals -1. So I plug that back into here. So I get 1 over x plus x minus 1 over x squared plus 4 dx. Okay, so now I'm ready to take the antiderivative. So the first integral, 1 over x, you know that's ln of x, that's easy. The second one, you have to do that not very profound, but very important step of breaking up the integral around this subtraction here. Okay, so I can just do this integral, that's ln of x, plus, okay, let's take the time to rewrite this, x over x squared plus 4 dx minus 1 over x squared plus 4 dx. So I just even put the negative on the outside. So ln of x just carries along for the ride. How am I going to do this integral? This integral needs an easy u substitution. So du is 2x dx. So that gives me a 1. Sorry, I shouldn't put an equal sign. Let me bring back. Okay. So let's bring this guy down here. So ln of absolute value of x. And then I would have a plus a 1/2 of integral of 1 over u du, right? Because I let the u equal the denominator, minus, wait a second, you recognize that. That's arctangent. X over 2 plus a c. So the last step would be putting in what the u is equal to. So that's 1/2 ln x squared plus 4 minus a 1/2 arctan of x over 2 plus a c.